In the 2014 higher level paper for question 1, what we see is that we have a water of crystallization question. So the first thing we're going to do is to go through the information we have and identify which numbers belong to which chemicals. So if we begin on the second paragraph, we see that a sample of the crystals was accurately weighed and found to have a mass of 2.50 grams. And those crystals are our washing soda crystals from up above. That sample was dissolved in deionized water and made up to 250 mils of solution. So for those crystals, there were 2.50 grams in 250 mils. A number of 25 ml portions of this solution, so that 25 mils still belongs to the sodium carbonate, were titrated with a previously standardised 0.1 molar hydrochloric acid solution. So that's my next solution now. So I have 0.1 molar hydrochloric acid. And the mean volume of hydrochloric acid solution required to reach the endpoint was 21.6 mils. So that belongs to the hydrochloric acid as well. So I'm just going to match those up to their chemicals in the balanced equation. And then we can go on to the actual questions, what we're being asked to do. So from the mean volume of the hydrochloric acid solution, calculate the concentration of sodium carbonate in the original solution in moles per litre and in grams per litre. So we're going to get it in moles per litre first. So E part 1. So we're going to start with the concentration we know. And the concentration we know is that we have 0.10 molar hydrochloric acid. So I have 0.10 moles per litre of HCl. But I know that I didn't use a litre of the HCl solution. I only used 21.6 mils. So to find how many moles are in 21.6 mils, I'm going to divide by 1000 and multiply by 21.6. And that's 0.00216 moles in 21.6 mils of my HCl. So I had 0.00216 moles of HCl. I need to find how many moles of sodium carbonate it took to neutralise that amount. So to do that I use my ratios for my balanced equation. So the ratio of HCl to sodium carbonate from above in the balanced equation is 2 to 1. So if I had 0.00216 moles of HCl, I had half as many moles of sodium carbonate, which is 0.00108 moles of sodium carbonate. But if I go back up to my information, I had that many moles of sodium carbonate in 25 mils of that solution. So that is 0.00108 moles per 25 mils of sodium carbonate. And then to get that into moles per litre, I need to divide it by 25 and multiply by 1000 to bring it up to 1000 mils. And that is 0.0432 moles per litre of sodium carbonate, which is what the question asked for, moles per litre. But now it wants grams per litre. So to convert my moles per litre into grams per litre, I need to multiply by the molecular mass of sodium carbonate. So if we add up the atomic masses, we have 2 23s for my sodiums, a 12 for the carbon, and 3 16s for the oxygens, and that will come out to be 106. So if I take my 0.0432 and multiply by 106, I get 4.5792 grams per litre. And that is part 2 finished for grams per litre. Now for part F, we're asked to calculate the percentage of water of crystallization. So that's the first thing we're asked to do. And then we're asked to calculate the value of X, so the number of water molecules in the formula. So first we're going to get the percentage of water of crystallization. So, for the percentage, I know I have 4.5792 grams in a litre, and that's grams of sodium carbonate in a litre of my solution. But up above, in the question, we see that we never made a litre of solution, we only ever made 250 mils. So I'm going to find how many grams of sodium carbonate are in 250 mils. So to do that, I take my 4.5792 and I divide it by 4. Because that's grams per litre. If I divide it by 4, that will get me grams in 250 mils. So I have 1.1448 grams in 250 mils of sodium carbonate. But I also know from above that I actually dissolved 2.5 grams of crystals in those 250 mils. And those crystals are made up of sodium carbonate and water. So if the total amount of crystals weighed 2.5 grams, but the sodium carbonate only weighed 1.1448 grams, then the rest must have been made up with water. So what I can use is subtraction there to find out how much water was in it. So if I take 2.50 grams and take away my 1.1448 grams, that will give me how much water was in those crystals, which is 1.3552 grams of water in the crystals. So my percentage of water is found by my mass of water over mass of the crystals times 100 over 1. So the mass of water was 1.3552 over the mass of my crystals, which was 2.50. Multiply that by 100 over 1. And we get 54.208%. So the percentage of water in those crystals is 54.208% by mass. That is the first part of part F done. That is the percentage of water of crystallization. Then to find the value of X, we have a formula that we can use. And you're best off learning this formula for your exam. The formula we use for the value of X is going to be the mass of water over the molecular mass of my water. I'm just putting an X on front because there's an X on front in the molecular formula for the crystals there. Because I don't know how many water molecules I have. That's what I'm trying to find. And that's equal to the mass of sodium carbonate over the molecular mass of sodium carbonate. So it's just the mass of one over its molecular mass equals the mass of the other over its molecular mass. So the mass of water, how much water did I have? I had 1.3552 grams. So I have 1.3552 all over the mass of water. And the molecular mass of water is 18. But I don't know how many waters I have. I have X waters. So I have 18 times X. So we put 18X down there. And that's equal to the mass of my sodium carbonate, which is 1.1448 grams. 1.1448 all over the molecular mass of sodium carbonate, which is 106. Now if I cross multiply, I get 1.3552 times 106 equals 18x times 1.1448. And then to isolate x on its own, we'll have 1.3552 times 106 all over 18 times 1.1448. And we end up finding that x is 6.97, and we usually round that to a whole number, so x is roughly 7. So the molecular formula of our crystals is actually Na2CO3.7H2O. It's the heptahydrate of sodium carbonate. And that is that question finished. We found what the value of x was.